Hello, geometry class, and welcome to this video talking about section 11.5, area of a regular polygon. We actually kind of saw this stuff when we did our trig unit, as it's going to come into play a little bit when we look at regular polygons that don't have a nice number of sides. So if we have a square, or as we'll see later in this video, an equilateral triangle or an equilateral hexagon, and not just equilateral, but regular hexagon, we could use 30, 60, 90 triangles to kind of derive what the area is going to be. But for just any regular polygon, there's a formula, and sometimes finding the parts of that formula requires some trig. So what I have here is a regular heptagon, and I chose the heptagon just to kind of say it really doesn't matter how many sides. This can work for any regular n-gon here. So don't just think this works for heptagons or anything. It can work for a polygon with any number of sides. All right. So we know that from our last unit that any regular polygon can be circumscribed by a circle. And if I go from the center of the polygon to a vertex, that's actually called the radius. So this is the radius of my regular polygon. And this altitude here, or I mean, it's an altitude because I'm eventually going to be drawing in a triangle, but this segment here that goes from the center to the midpoint of the opposite side and makes a right angle, we've seen this before too. That's called the apothem. So we're going to use the lowercase letter a to stand for apothem. That's the apothem of my circle. And that a is going to be part of my formula. Although keep in mind, when we have a polygon with like 5 sides or 7 sides or 10 sides, we're going to be using some trig to find out what the apothem is. Okay, so what is the formula for the area of a regular polygon? It's 1/2 the apothem times the perimeter. And where does this come from? Well, I can essentially break the polygon up into triangles, and the number of triangles that I can break it up depends on the number of sides. So if I draw in all of my radii, there are obviously going to be, in this case, 7 radii because there are 7 sides because there are 7 vertices. So the number of radii depends on the number of vertices, which depends on the number of sides. So I can break this shape up into n triangles. And I'm going to find the area of the polygon by finding the area of one of these triangles and then multiplying that by the number of sides. So each triangle has a base down here, which is equal to whatever the side length is for the polygon. It's regular, so all of the sides have the exact same length. So I'll just call them all S. And the area of this triangle here is going to be equal to 1/2 times the base, which is S, times the apothem. And if I want to find the area of the regular polygon, I'm going to multiply this by the number of triangles, which in this case is n. So I'll multiply both sides by n. And I get that this is the area of my regular polygon. And that's equal to 1/2 S times n. That's the side length times the number of sides. What does that actually find? If you multiply the number of sides times the length of each side, when they're all the same, you get the perimeter. So I get 1/2 the apothem times the perimeter. And that's where the formula for an area of a regular polygon comes from. As I said, this apothem sometimes is difficult to find, but you can see how we're going to use trigonometry to get it. So this altitude, because the triangle is isosceles, is going to cut the base in half. So I can find out, if I know the side length, I can find out what this is just by dividing it by 2. And then this angle is the angle of a regular polygon. That's n minus 2 times 180 all over n. And the radius is an angle bisector. It's going to cut that in half. So we'll just throw another 2 down there. That's how we're going to get this angle. And then the apothem is the opposite side of that angle. There's the adjacent side. So you can see we're going to be using the tangent function. Okay, to the nearest tenth, find the area of a regular decagon whose perimeter is 16. Okay, so regular decagon, there's a whole bunch of sides here. Not that important. What's important is that I find the apothem. That's what I need. So If the perimeter is 16 and it's a decagon, that means that n is 10. And if the perimeter is 16, that means that the side length is 1.6. Okay, when I draw this triangle, I'm looking for the apothem. I'm looking for A. That's half the side length, so this is 0.8. Okay, so now I need to find out what this angle is so that I can cut it in half. Okay, for a regular decagon, it's n minus 2 times 180 all over n, and here n is 10. So that's going to tell me I have 10 minus 2 is 8. 8 times 180 is 1440 divided by 10. It's 144. So this half angle is then going to be 72 degrees. Now we have enough information to find out what the apothem is. I'm just going to write the equation that the tangent of 72, remember we always take tangent of an angle, is equal to the opposite side, A, over the apothem, 0.8. So I'll multiply both sides by 0.8, and I will get that my apothem, and here I am using a calculator. I don't even know if you can see it because I haven't shared this, but I have a lot of things memorized. The tangent of 72 is not one of them. So I get that the apothem is 2.4621. 2.4621. Okay, I have my apothem, I have my perimeter, I'm ready to plug into my area formula. Okay, sorry about that. So my area is going to be 1/2 times 1.6 times 2.4621. And that gives me a final answer of 19.7. 19.7. There we go. That's the area of our decagon. Okay, some special formulas for an equilateral triangle. I know that each of these angles is 60. Let's call my side length S, and let's see if we can get a formula for the area in terms of S. All right, well, my perimeter is 3S, and there is my apothem. So we can see that, let's see, if this is 60 degrees, this cuts it in half, that's 30. This over here is S over 2, so my apothem is going to be S over 2 rad 3, or rad 3S over 6. So my area is going to be 1/2 times the apothem, rad 3S over 6, times the perimeter, 3S. Okay, now let's start canceling. This 3 can cancel with a 3 down there, which will make it a 2. And my S times my S is S squared. So I get S squared times rad 3 all over 4. This is my formula for the area of an equilateral triangle. Okay. For a regular hexagon, we're still going to be using 30, 60, 90 triangles. The radius and the side length are all the same. So I get an equilateral triangle there. So my side length, again, we'll call it S. What's my apothem going to be? Well, here is another 30, 60, 90 right triangle. This is S over 2. So my apothem is going to be S over 2 times the square root of 3. So my area is 1/2 times the apothem, not opossum, S rad 3 over 2. And my perimeter is 6S. So again, let's cancel. The 2 cancels with that, makes it a 3. And I get 3 times the square root of 3 times S squared all over 2. And that is my formula for the area of a regular hexagon. Okay, Last problem, I think. Yep. Last problem we're going to be looking at is find the perimeter of an equilateral triangle whose area is 108 square centimeters. Okay, so they're giving us units. We're going to give units back in our answer. We're going to start by using the formula that we just came up with. S squared rad 3 over 4. This is equal to 108. So I'm going to solve for S and then triple it. Okay. So I'll start by multiplying both sides by 4. So S squared rad 3 is going to be equal to 432. And now I'm going to divide both sides by rad 3. So S squared is equal to 432 rad 3 over 3, which is equal to 144 rad 3. Okay. Now I'll take a square root, and this isn't an algebra class, so I'm not going to ask you to simplify this. Although what you would get is 12 times the fourth root of 3. If you really wanted to write it in simplest radical terms, 12 times the fourth root of 3. But we don't have to write it like this. I would say we're probably better off putting this in simplest, in rounded to the nearest tenth. So let's figure out what 144 times the square root of 3 is, and then we'll take the square root of that. So I'm getting that 144 times the square root of 3 is 249.4. I'm going to take the square root of that, and I get 15.79. And since they want the perimeter, I'll triple it, and I get 47.37, or 47.4 is my final answer. So my perimeter is 47.4 centimeters.